What we need to talk about here next are what are known as the limits at infinity. We're going back to the limits for just a bit and talk about limits a little bit more. Okay, and just to refresh our memories on some of the things we did with limits a few days back, I realized, but yeah, we were talking about limits such as x approaching 2 of, well, let's just do x minus 2 over x squared minus 4. We did stuff like that before. That was the type of limits, and of course they probably got a little more complicated, but that was the type of thing we did. And we did that one just to review. This is not how we're going to do this, limits at infinity, but we factored, right? Because we couldn't plug in. We factored. Because we plug in, we get the bottom to be 0. But we factor it. The x minus 2's cancels, so we get it down to this, which now we can evaluate, right? 1/4. All right, well, the way we're going to do limits at infinity is not like that at all. Okay, just reminding you what we did previously. And matter of fact, derivatives had, the definition of derivative had to do with limits. But limits at infinity, it's a little different thing. It is pretty much just what it suggests. So look on the handout there on number 1. I'll just draw it up here. On the handout number 1, to get the graphical perspective here, so this is some function x, okay? So with those over there, graphically speaking, I was interested in what was happening as you got closer and closer to 2. Well, guess what? Limits at infinity are interested in. What happens as x goes to infinity, either positive infinity or negative infinity. So as x goes to infinity, we're talking about out here, right? So we're interested in what happens to the graph as you go further and further out to infinity. What happens on the number 1 as x goes out to infinity? Well, I drew the nice little horizontal line at L there because, yeah, this graph levels off at L. And so for that reason, we would say the limit as x goes to infinity of f of x is L. With me? Makes sense. So yeah, the change is, instead of looking at what happens as x goes to a number, I'm looking at what happens as x goes to infinity. In this case, it levels off at L. All right, number 2 kind of goes the other way, doesn't it? With the leveling off anyway. On number 2, it's looking somewhat like that. So what have I got as far as a limit at infinity? Don't I have a limit as x goes to negative infinity on this one? Yeah. In this case, the limit of f as x goes to negative infinity is L. Okay. All right, and so we looked at tables and things. I don't have a table for these, but be the same idea. If I let my x values go out here to negative infinity, say negative 10, negative 100, negative negative 1,000, what I would see, I'm not even going to put the values in, but what I would see is the function values are getting closer and closer to L. So it's a little bit, we're talking about a little something different. Back on those, we were looking at as x approaches 2, so we did 1.9, 1.99, but for these, I'm not sure we'll do any tables on these, but if we did, the x values table-wise they would go out to either negative infinity or positive infinity. And then these would need to go to some number L, whatever it may be. Okay? All right. Now the other definition I might mention here is that, yeah, if either x equals infinity, x going to infinity, the limit is L, or the limit as x goes to negative infinity is L. If either of those happens, then we also have, if we have either of these, we have a horizontal, what's called a horizontal asymptote at y equals L. Horizontal asymptote at y equals of y equals L. Okay. All right. So that's the graphical perspective. Well, I've got one more of those. Number 3. Let's talk about number 3 on the handout. Let me ask you a couple of things. Draw it up here if I can. Got a nice little drawing here, graph. Yeah, haven't seen many exactly like that, but that's what I got. Okay. For this break, looks like it's a -1. I'm off a little bit. 1 and then 2. Looks like this break happens. Well, it does happen at 2, doesn't it? Okay, something like that. And this here is about 2 there. This one's up there at about 5. Okay, vaguely resembles what I've got on the handout there. All right, so a couple of quick limits for you here. What is the limit as x goes to infinity of f of x? Limit as x goes to infinity, f of x. Does it have one? It may not have one. You know, we could have, at infinity, we could have a limit as x goes to infinity of infinity, or negative infinity. That could happen, but I don't think so, not on here. What is the limit as x goes to infinity for my function f here, number 3? Well, that looks like as x goes out to infinity, it's leveling off right there at 5. The handout's a little clearer there, I think. 5? Is that what you see? Okay. Yeah, it looks like that's leveling off at 5. So what about the limit as x goes to negative infinity? Well, that's the one down here, isn't it? As you go out to negative infinity x, looks like the leveling off is at 2. What about c here? The limit as x approaches -1. What do you got there? Well, that's kind of back to the things we talked about previous. There is there is a limit as x approaches -1, but it's we call it something. It's actually not a value, but what would the limit as x approaches -1 be? Infinity, yeah. Now, the thing about as you approach a number, remember, you got to look at both sides. So as x approaches -1, we got to look at the left and the right. So that's a little bit of a difference, but both of them go to infinity, yeah. All right, then D, what about the limit as x approaches 2? that's a no-go, right? Does not exist. Why is that? Well, it's because the limit as x approaches 2 from the left is what? As you approach 2 from the left, it's negative infinity. And then as you approach limit as x approaches 2 from the right, that's positive infinity. And the two don't match up. They matched up on -1. Both sides did, but not on that one. Okay, and the other thing they'll ask, E part, what are the equations of the asymptotes? Equations of the asymptotes. Well, yeah, we just talked about the horizontal ones. I do have two horizontal ones. I've got one at 5, and I've got a horizontal one at 2. And remember, on the horizontal ones, their equations are y equals a number. So it's y equals 5 and y equals 2. But then I also have vertical asymptotes, and the vertical asymptotes are x equals a number. So we've got a vertical asymptote at x equals 1 and a vertical asymptote at x equals 2. So that that's the difference between those two. With me? We have to draw